So here is the 50-59% work packet. Of course, you're doing this on a DS, so your problems will be very, very similar, but in most cases different, but not always. So I'll run through them real quick, and then you'll have to do your similar problem. So here I just want in problem number 1, the f of -7. Here's function f, so we put in a -7 for x. We do it in our notation on the left, and then we do it in the actual function, the expression on the right. So you can see every place there's an x, I put in a -7. I also put it in parentheses when I wrote it, and that helps keep me correct. Okay. Now you don't work on the left-hand side, you just work on the right-hand side. The left-hand side is saying the f of -7 is, and then the right-hand side gives the answer to it. -2 times I squared -7, so it becomes positive. I multiply, and that becomes positive. 2 times 49, that's -98 plus 20. 1 minus 1 is -98 plus 20, or -78 for me. So that'd be my answer to number 1. Number 2, we're just solving a linear inequality. It says answer in interval notation. So there's my variable n. I want to get my n alone, so I'm going to start immediately by adding 6 to both sides. That inequality is my left side, right side divider right there. So 6 and -6 there, they add up to 0. So I have -n over 5 on the left, and on the right, 7 plus 6 is 13. See, I got to get rid of this division by 5, so I'll just multiply by 5. 5 over 5 now is 1, and 5 times 13 is, what, 65. Now to get rid of this -1, I don't want a negative n, I just want positive n. So I'm going to multiply this side by -1, which makes it positive. But I have to multiply the other side by -1 to keep it balanced. And because I multiplied by a negative, I got to flip my darn inequality to keep it true. So n has to be bigger than -65. On a number line that looks like this, here's -65, and bigger than would be to the right. Now they want interval notation, so when I write interval notation, I say, well, it starts on the low end at -65, using a parenthesis because the circle is not filled in. I don't want to know where it's equal to -65. And it goes to the right, and to the right is positive infinity, so that's what I say, it goes to the right. So -65 to infinity with parentheses on both ends. Number 3 here. Let's solve a little equation here. So we'll clean up each side individually first. Distributing gives me a positive 16 there. Equals, and then on the right-hand side we distribute 6x minus 22. Now let's go ahead and get all our x's on the same side. -10x plus 16 equals -22, and now it's a 2-step problem. Get rid of the 16. -38, and divide by -10. So x equals 38 over 10. Of course, we'll reduce that fraction to 19 over 5. Or if you wanted to, you could put 3.8. All of this or this would be correct. Problem 4, which inequality is represented by the number line? Well, this starts at 1, 2, 3, that's 4 right there. So it starts at 4, and then you're bigger than it. So we want the x's that are greater than or equal to 4. So when you're describing or writing your inequality, you're describing x, and x is represented by the points that have the blue dots over them. So all this blue stuff here. So those x's are all x's like 5, 6, 7 that are bigger than 4, greater than or equal to 4. Problem 5. 5. Which ordered pairs are solutions to the inequality y is less than -3x minus 6? So trying to think of what would be the simplest way to do it. Probably easiest is just plug in your x and y values and see which ones are true. So I'm going to plug in, for like this first pair, it says when y is -4, and I'm going to put a 0 in for x. See, negative 3 times 0 is 0, so negative 4 is less than negative 6. That's false. Negative 6 is less than negative 4, so it's not this. Now we're supposed to pick more than one possibly, so if we find anything else that's true, we'll have to pick it. Let's see here. If I plug in negative 43 for x, or for y, then the x has to be a 10. See if that's true. Negative 43 is less than negative 36. That's true. So that holds for the equation. Let's try when y is 9 and x is negative 4. Let's see if that's true. 9 is less than 6. That is not true. Let me get rid of that one. 12 and 41, negative 41. Put 12 in there. Oops, minus 6. Negative 41, are you less than negative 36? Minus 6. Negative 41, are you less than negative 42? No, you're not. If you think about a numbered line, here's negative 41, here's negative 42. Negative 41 is bigger. It is closer to the 0. So no, that one does not work. And we will check the last one. See, when y is 16, can x be negative 10? 16 is less than, that's going to be 30, positive 30 minus 6. 16 is less than 24, that is true. Number 6, this is better now. Just solve this thing for a. So here's our a's. So let's distribute to free the a's from the confines of the parenthesis. Got some like terms here on the left-hand side, so let's clean those up, get them combined. All right, now we'll get our a's on the same side, and this will get us down to a two-step problem. That's negative 25a. Oops, that 7a is gone, so it's just 2 over there. So we are down to now just 2 steps. Let's add the 29. Negative 25, a is greater than or equal to 31, and we'll divide by negative 25. When we divide by negative, we got to flip the inequality, and we get negative 31 over 25 here. Okay, and we just leave it as that messy fraction. I guess as a decimal, that's negative 124 over 100, so negative 1.24, I guess, would be the decimal. I would just write, they don't say answer an inequality, so I would just leave it like that. All right, that takes care of page 1. There it all is on the screen at a time. Took about 8 minutes. So page 2 here. See, solve this combined inequality. What we'll do here is we'll just simply work it here at the same time. Here's our separators. I got to add 5 to both sides of the equations here. So on the left, I get negative 25 is less than or equal to 5x, which is less than or equal to negative 5. Now we got to divide everybody by 5. It's a positive, so we don't have to flip anything. Negative 5 is less than or equal to x, which is less than or equal to negative 1. Answer as an interval. Let's take a look at this graph here. X is trapped between negative 5 and negative 1. So there he is. When we write interval notation, we put the low number on the left, high number on the right. If you include it, because the dots are filled in, because it's equal to up here, we have to put the hard brackets on it. So there's the interval of the x's that make that inequality or combined inequality true. Number 8, identify the correct one. So right here, this is at negative 1. So this is x is less than negative 1. And this is 5 right here. So this is x is equal to 5 or greater than it. Let's see, it's not this one because of that. It's not this one because of that. So it could be this guy, he's less than 1, or x is greater than or equal to 5. There you go, right there. Solve this. This is an OR statement. So we just solve them individually. Here's our separator here, so we'll subtract 8. Giving us 5y is less than negative 15 divided by 5. So y is less than negative 3 or equal to it. Let's move our 14 over, just a two-step little problem. See, that's 25 divided by 5. Y is greater than or equal to 5. So we are less than or equal to negative 3. Now they want interval notation for this. It looks like this. Less than negative 3 goes to negative infinity up to 3 inclusively. Combined with, we use a big U in there. It stands for union. And it starts up at 5 and includes the 5. And it goes to positive infinity. Okay, so if you think about it, here's what it looks like on the number line. Here's negative 3, and it's less than or equal to it. And then here's positive 5, and it's greater than or equal to it. Oh, no, it's not. This is just a greater than up here. So I got to erase a little bit, get rid of my greater thans, which will make it an open circle there. And going to the right, like that. There we go. 10, we just have to graph. This thing's already in y equals mx plus b form. So our y-intercept is 1, and our slope is the negative 3/4. Y-intercept is 1 is right there. And it says go down 3 and over 4. So I'm going to go down 1, 2, 3, then over 1, 2, 3, 4. And I'm going to put my dot right there. There's my dot. And I can go again down 3 and over 4 if I want to. It's a negative slope, so it better go up and to the right. Oh, I missed that one. Let's try again. There we go. That's not too bad. And our line should look something like that. And that is page 2. Simple enough. That one took about 3 minutes. 4. Problem 3, or page 3. We got to graph this guy too, but he's not in slope-intercept form. Okay, he's in standard form. This is ax plus by equals c. That's no problem. Let's see here. Let's move the 5x over because we want mx plus b on the right-hand side. That gives us 9y. The 5x is now on the right-hand side, and it's positive. There we go. Almost y alone. Got to divide by 9 everywhere. So there's our slope, 5/9. And 45 over 9 is just 5. So y-intercept, slope. Y-intercept 5. There's a big dot at 5 on the y-axis. And then our slope says go down, up 5 and over 9 right there. Or I can go down 5. I'm going to do that. And back 9. So it puts me right there. And also up here if I want it. But there is my graph. 12 is transformation of function g. T is the transformation of g. Let's see here. T is graphed below in blue, so T is in blue. Let's put him in blue. And the black one is G. And we want to figure out how T has been transformed. So I'm going to zoom in here really close here. And you can see if I look here, this is at a half. It looks like 1, 2, 3, 4, 5. So there's one step to the next half. There's 2 steps. There's 3 steps. There's 4. So it is 1, 2, 3, 4 higher. So it's taken whatever function g is and moved it up by 4. Well, that's going to be easy enough, I hope, here. There we go. So to move something up by 4, remember our function notation and our vertex form, a times x minus h squared plus k. Remember, h controls left and right, k controls up and down. This is moved up by 4 units, and so therefore we want a k value of 4. So it's g of x, but then 4 has been added on the outside to move it up. And that finishes page 3, I think. Page 4. Function f is a transformation of h. F is blue. So f is where we started, and it is a transformation of the black one, h. So how has it been transformed? It looks like it's been moved up by 1, 2. So we just got to find one that added 2 to the outside because it slid it up, and outside is our up and down. So we'll choose that guy. Number 14. Solution to the system. This thing is almost set up to add these two equations together, but right now if I add them, this would add up to 20x's and this would add up to 4y, so nothing would disappear. So what I'm going to do is I'm going to take this top equation times a 3. It'll make this -6 right here, and then it would add to that 6 to cancel out. So let's do that. I'm just going to take this top equation. I'm going to multiply him times a 3. Now I got to do it to everybody. So I get -15x. That's this. I get -6y. That's what I wanted. And I get negative 3 times 9 is 27, carrier 2. 3 times 4 is 12 plus 2. I think that's 147. That sounds right. And I'm going to line that up with the other equation. Now, the other equation I'm not doing anything to. I'm just going to rewrite it. Because it now has the 6y, and I've got a -6y above it. And so when I add those two, the y's here eliminate each other. See, -15 and 25 is 10. 147 and 17. Let's see here. 53 would be 200. So 53 plus 17, 70? I believe that comes out to 70. Yeah. Divided by 10, looks like x is 7. Now don't forget, once you find x, you got to find y. I'm going to use this original equation right here. -5x minus 2 times y, but y is 7. We just found it. Equals -49. It's -14. Let's add that 14 to both sides. Two-step problem at this point. It's -35, I think. And I divide by -5. I get 7, it looks like. Oops, this should be a y. No, it shouldn't. That should be an x. Oh, crud. I substituted in for the wrong thing. Go back here, -5. X here is 7. That was right. I put my 7 in there. 35 minus 2y equals -49. Add your 35 to get rid of it here. Add your 35 there to keep it balanced. 2y equals -14, I believe. So y equals 7. It looks like this way. 7, 7, which explains why I substituted in for y a 7 and out came a 7. Because 7, 7 is where these two cross or intersect. Problem 15. Find the equation of the axis of symmetry of the following. We had a formula for that. Axis of symmetry from the standard form. A is -3. B is -1. And C is -7. Okay, so the formula for the axis of symmetry, the opposite of B, and B is -1, over 2 times A, and A is a -3. Let's see here. Double negatives, and 2 times -3 is -6, so I'd probably put the negative on top. So x equals -1, 6. So if you thought about a coordinate axis, here's -1, let's call it. So -1, 6 is right about there, and that'd be the axis of symmetry. This parabola opens upside down. But there it is, the axis at 1/6. Remember, it's always just a vertical line. 6, determine whether the following graph relationship is a function. This is a test called the vertical line test. If a vertical line only hits it in one point, it is a function. If you can draw a line anywhere that hits it in 2 spots, but no matter where I draw a vertical line here, and let me pull out maybe a vertical line here. See if it'll do this. There we go. So there's my vertical line. Now let's see if I can just kind of move him. So if I just move him. Anywhere I put that vertical line, it's only going to hit this graph in one single point. And what that means is every single x pairs with exactly one y value. Okay? Had there been another part of the graph up here, then it would have gone through 2 points of the graph, and that would not be a function, because then when x is, I don't know, about -6, it's going to 2 different y values. Functions don't do that. This one passes the vertical line test. Vertical line only hits it in one spot, no matter where I draw it. So yes, function. No, down here, I guess. All right, next page. Page 5. Classify the function. This is quadratic because it makes a parabola. Linears make lines. Square roots, they make parabolas, half a parabola on their side. Exponentials, they look like this. Get low on one end and high on the other. Parabolas are all quadratic. Number 9, solve the linear inequality for b. Divide by -9. This is just a test to see if you remember to flip. See, I divided by -9, and so I have to flip the inequality to make it a greater than. It says interval notation, so on a number line, if you think about it, -9, and I want to be bigger than it, so that's to the right. And so my interval is from -9 to the right, which is positive infinity. Always put a parenthesis on infinities. We don't know their end. All right, number 20. I wish I had a calculator for this. So I'm going to grab one here because I'm going to do some distributing. So here we go. I distribute the one. No, I'm not going to. I'm going to do something different. I'm going to divide by 1.3 on this side and 1.3 on this side. Okay, so 1.3 over 1.3 is just 1. Show how I just zoomed in there. So the left-hand side becomes just z minus 15.1. Over here, I'm going to do this division. I think that comes out nice. Yeah, it comes out to a nice 5. And by doing that, I don't have to distribute on the left, and on the right, I'm distributing a nice number. 1.8 times 5 is 9, and I believe 5 times 1.6 is 8. So I'm getting really nice numbers now. I'll subtract my 9z, giving me -8z. I'm going to go ahead and move my 15.1 over as well. Equals, let's see, that's 23.1. I just have to divide by -8 and I'm done. I don't have to flip my inequality because it's an equation. And 23.1 divided by -8. Z equals -2.8875. I don't know, maybe a fraction would be nicer. Z equals 23.1 over -8. So you could write this as -231 over 80. Just multiplying top and bottom times 10. I think that's all they're divisible by. So that fraction or that decimal. Let's see here. Turn that off, hopefully. All right, let's see here. 21. There we go. Find the equation of the line that is parallel to this guy. Let's look at that guy first. His slope is 1. How do I know that? It's the number in front of the x. This is y equals mx plus b. They didn't show the 1, but it's implied. So the slope that I want to be parallel to has a slope of 1. So I have to use the same slope. Think about a slope of 1. It goes up 1 over 1. If I'm going to be parallel, I have to go exactly up 1 over 1 as well. So I know I got to use this slope to be parallel, and then I got to go through this point. We have a point-slope equation. They gave us a point and a slope. This is what our point-slope equation looks like. It's called point slope because you have to put in a point, x1 and y1, and you have to put in a slope. Well, we got a point, and they told us it goes through negative 6, 9, and they told us a slope, or they said use the slope one because you got to be parallel. And so we just substitute in. Here's my x1, y1, my slope. And so I rewrite this equation. And I go y minus y1. Well, what's y1? Well, y1 is a 9. Okay, and that equals m. Well, what's m? M is a 1. See here, then parentheses x minus x1. What's x1? x1 is negative 6, so I get minus 6. Note that double negative you get there. So let's clean this up. 9 equals, this just be x plus 6. So y equals x plus 15. I believe that's our answer. Look at his slope here. He has a slope of 1, same as this line, so they're going to be parallel. It has to go through negative 6, 9. So if I plug in a negative 6 for x, negative 6 plus 15 is 9. So it goes through that point. I'm done. 22, the difference, so subtraction, of 4 times a number and 1. So there's a difference of 4 times a number and 1 is 37. Now, I don't really know if it's 4x minus 1 or 1 minus 4x. Both are a difference of those two things. I might want to cover them both. And to cover them both, I could just do this. And that implies 4x minus 1 equals to 37, or it's going to equal, if I divide in the other, or subtract in the other direction, I'll get negative 37. So for x equals 38, x equals 38 over 4. Divide by 2. Add 1, that's 36, and divide by 4. So x is either 19 over 2, or it is never negative 9. Now, of the two, I'd probably pick this one. They said the difference is 37, not 37, so assuming x is, I don't know, positive, I guess. But they both have a difference of 37. One just is negative 37. There's page 5. Page 6. I'm checking on my time here. I'm trying to do this within one class period. Solve the absolute value equation. Yeah, I just did one very similar to this. I'm going to isolate the absolute value by subtracting 10. And then you have to write two equations. One for the stuff could be positive inside, excuse me, and one for the stuff could be negative. And then we just solve these. Add 9. Divide by negative 6. Add 9. Oops. Divide by negative 6. There we go, 2 answers. 27. Ooh, there's our absolute value. We gotta get that thing isolated. So let's first get rid of the 6. Now we gotta divide away the 7. And I get 6a minus 41 in absolute values is greater than or equal to 1. Two equations now. 6a minus 41 could be greater than 1. It'd be more than 1 unit away from 0 then. Or 6a minus 41 could be less than or equal to negative 1. You got to flip it and change the sign. Okay, it pushes you greater than 1 unit away from 0 and less than negative 1. That less than negative 1 pushes you more than 1 unit away from 0 as well. Two little equations to solve. Add 41. 6a is greater than or equal to 42. Divide by 6. Add 41. You get 40 over there. Divide by 6, and you get 40 over 6. Or divide by 2. So I'm greater than 7, and less than 20 over 3. Inequality notation. Let's take a look at this thing. Here's 7. Now 20 over 3 is 6 point, I might have to move my 7. 6 and 2/3, so 6.6 repeating. So I'm greater than 7 this way, but I'm less than this 6.6, the 20/3, this way. Inequality notation, I just write it the way I see it there. We're just going to write x is less than or equal to 20 over 3, or x is greater than or equal to 7. We just make those two statements. Absolute value. Let's do our 2 steps here. Gotta subtract that 5. Gotta divide away that 3. And we just got 2 problems to solve. We have to solve it the way we see it. 8x plus 15 is less than or equal to 17. And we got to solve it again, but this time we got to say greater than, flip it, and change the sign. So 8x, subtract 15 is 2 8s, or 1/4. So x is less than 1/4. Let's see here, add or subtract 15. Divide by 8. So in this case, if we look at the graph, we're greater than -4 or equal to it. We're less than or equal to 1/4, which would be on the other side. Greater than, oh no it isn't, that's a -4. There we go. And less than 1/4 or equal to it. There you go. Inequality notation. So this one we can write in this abbreviated form. X is trapped between -4 and 1/4. Just like that. 26. This is another one like the very first problem. They want n to be -5, so you just replace the n with -5. Note again, I'm using parentheses. That should be -6. Putting in my -5 in parentheses. Square first. So that's 625, so that's 150. Multiply, so it's going to be plus 30. Let's go ahead and write 38 here, because 30 plus 8. And so 188 would be our final answer. Solve the system by graphing. So here's our first one. Y-intercept -5, slope up, down 3. 1, 2, 3 over 2. Up 3, back 2. So something like this. Then the other equation, y-intercept is 0. It goes down 1 over 4. Up 1 over 4. There's where they cross. Cross right at that point. That's at -4, 1. That's the solution to the system. Where do they cross? See, these had to be put in slope-intercept form. Move my 6x over by adding it to both sides, and I'll divide by -4. -3 over 2, just simplified the fraction. Y-intercept -3, down 3 over 2. Up 3, back 2, up 3, back 2. Something like that. And blue here, -2y equals x minus 2. Add x both sides. Y equals -1/2 x plus 1. Y-intercept 1, down 1 over 2, up 1, back 2, up 1, back 2. There's where they cross. A terrible line drawing, but that's at -4, 3. And that's the solution to the system. It takes care of page 6. Problem 7. Solve the system. I'm going to use substitution. Plug it right in for that. Y minus 5 plus 3y equals 23. 4y is minus 5. Just add my y's together. Let's add 5 to both sides. That's 23, giving us 28. And divide by 4. So y is 7. Put the 7 in there. X equals 7 minus 5, which is 2. So x is 2 and y is 7. And we're done. Substitution. This one I'd probably do with linear combination. 35 right there. If I take this negative 7 times 5, it'll be negative 35, and they'll cancel. So I'm going to take this one times positive 5. Gives me negative 35x, negative 25y, equals negative 210. There we go. Line it up with my other equation. Don't have to mess with it at all. This is going to be nice. Negative 21y equals 0. Divide by 21 or negative 21, you get 0. So I know y is 0, so I plug it into the first equation for y. 5 times 0 is 0. Divide by negative 7, I get 6. So these two must cross when x is 6 and y is 0. Choose the ordered pairs that are solutions to the system. You just have to test 4, 4 in this and this, and test negative 6 in this and this. And if it fits and makes both of them true, then choose that answer. This solve the system of equations using elimination. We got to pick two equations, eliminate a variable, pick a different two, eliminate the same variable, and so on. I'm going to pause right there, and I'll finish up later. So let's go ahead, get rid of that, I hope. And we'll try to solve this guy right here. So, as I set it up here, I'm going to use this line right here, because that has a single x. I'm going to use this line to get rid of this line, this 3x here, and I'll also use it to get rid of this 2x. So first, I'm going to make a combination of equation 1 here. Then I'm going to take this third equation and park it right underneath it. I'm going to take it times a 2, giving me a 2x, a minus 4y, plus 16z equals a 60. I'm going to add those two together. Negative 12y plus 24z equals 48. Since everybody here is divisible by 12, I'm going to go ahead and do that. In fact, I'm going to do negative 12. And I'm just doing the same thing to both sides. Dividing everybody by negative 12. And it comes out to that. Now, I'm going to do the same thing, but this time I'm going to use equation number 2 here. So I'll rewrite him. And this time I'm going to take equation 3 and I'm going to multiply him by a negative 3. And you'll see why in a second. That gives me a, so I'm taking it times x, negative 3x, that's y, the negative 3, times negative 2, so that's positive 6y, times positive 8, so that's negative 24z, and then times 30, negative 90. I add those two up. It's 15y minus 30z equals negative, I think that's 59. I wish it was 60. Why is that 31? Throws everything off. I don't see any mistakes, so it must be this ugly problem. So now I've got this equation and this green equation. Now I've got to use elimination again. So I'm going to take the first equation here times a negative 15. And y negative 15, well, I'm going to line it up with this blue one, and it's got a positive 15y there. So by multiplying by negative 15, I'll get a negative 15y to help me eliminate stuff. So here comes my multiplication. Negative 15y plus 30z, and 15 times 4 is 60. It'll be positive. I'm going to line it up with my blue one, which is positive 15y minus 30z. And it looks to me like I get 0 equals 1, and therefore There are no solutions, because that is a false statement. Problem 33, graph the quadratic function. So this is in that a times x minus h squared plus k form. And there's no k out here. Okay, so it's not shifted up or down at all. Remember, k controls up and down. X plus 5, that's going to shift it left by 5 units. So it's going to start right there in your axis of symmetry. So it shifts left 5. It opens up. So this is going to look like y equals 2x squared, just counting from this point right here. And so you can just generate a few points here. 0 is a 0, 1 squared is 1 times 2, and 2 squared is 4 times 2 is 8. So we just count from this point. This is like our new origin. This would be the location of 1, 2 right there. And this would be the location of 2, 8 right there. And so we can just mark those points. Here's 1, 2, and here is 2, 8. And then symmetry gives us points over here. And that's a pretty good graph. 34, find the y-intercept of the parabola with the following. So when you're looking for the y-intercept, your x has to equal 0. So we're just going to put a 0 in here for s in this case. Y equals negative 10. So when s is 0, y is negative 10. That is the y-intercept. Okay, it's also just that number dangling off the end. All right, here comes page 8. Find the smallest value for y. So this is asking for a minimum here. Because smallest implies tiny, minimum. For which following quadratic equation, enter negative infinity if there is no smallest value. Well, if you think about this graph for a second, see this a up here? Remember, that controls whether it opens up or opens down. Positive a's open up, negative a's open down. So this parabola, no matter where it's at, is opening upside down. Which means, does it have a minimum value? No, it has a maximum, a highest point. But it goes down to a lowest point of, well, down is negative infinity. So this one just goes to negative infinity. Had it opened upward, then it would have a lowest point, a minimum value. 36. How many x-intercepts does this parabola with the following equation have? Okay, to do this, we can graph this thing. Now, I would just graph it with a graphing calculator, but I'll do it here real quick by hand here. First thing I would calculate is negative b over 2a. My axis is symmetry, so it's negative of negative 50, because b is negative 50, over 2 times a, and a is negative 5. Double negative, so we get 50 over negative 10, which is negative 5. All right, so I know that this parabola, when x is negative 5, there's its axis of symmetry. And to figure out the y value, where it lies on this axis of symmetry, I just plug that x in, negative 5, and figure out what the y value is. So I'm going to plug in, I'll go y equals negative 5, and I'm going to put in a negative 5 for x, because that's the x value where it has the vertex. Comes another negative 5 in there, then minus 125. So I square the 5 first, that's 25, and then take it times 5, negative 5. So that's negative 125. 5 times 5 is 25, so this is plus 250. Minus 125. See here, that gives me 0. So this parabola hits the x-axis right there. It opens down because the a is negative. So how many x-intercepts does it have? Well, it has 1. Okay, had it crossed it in 2 spots, we'd say 2. But it doesn't, only hits it in that 1 spot. So look at 37 here. Identify the correct equation of the parabola. So this thing is shifted to the right by 1, 2. Let me zoom in there for you. Hopefully. There we go. So I'll count without my pen. So it shifted right 1, 2, 3, 4, and it shifted down by 1. So when I'm thinking about the equation, here's my vertex form. Remember, H controls left and right, K controls up and down. So this is shifted to the right by 4. So I want X minus 4, because a positive 4 would make this 0 in here. So that moves it right 4. And then it's bumped down by 1, so minus 1. Now, I don't know my A value yet. I could calculate that if I wanted to. I could pick a point that I could read, like that point right there, plug it in for X and Y and find A, but I don't think I'm going to need to do that. Because if you notice, all my answers have A as 2 in front of them, so I know A must be a 2. I'm just looking for the X minus 4, and the plus 1, I want minus 1. X minus 4 minus 1, this guy right here. Moves it forward, right, and down 1. See, this next one shifted left, it looks like, from the origin, shifted left by 10. So that's going to be X plus 10 squared. That will shift it left. And then it shifted down by 6, it looks like. So minus 6. Looks like the A value is just a 1 based on all these. So I'm looking for X plus 10 squared minus 6. It looks like that guy right there. 39, we've just been working on factoring. Notice your A value here is 1. We like it when it's 1 because it'd just be Y and Y. And to get 35, because we just have to worry about the C. 1 and 35 are 5 and 7. You want the 5 and 7. And there you go. Y minus 5 times Y plus 7. Let's factor this guy. Again, the A value is just 1, so it's A and A. To get 12, 1 and 12, 2 and 6, 3 and 4. I want them to add up to 7. So I'll do A plus 3, A plus 4. There's my factorization. And to the last page now. You can see these don't take too long. Solve for Z. So these are ones without a B term. So I'm going to add 7 to both sides, and that gives me 3. I'm going to divide by 9, and I get 3 over 9. Now I could simplify that radical at that point, or that fraction. I'm going to leave it as 3 over 9 because I know my next step is to square root it. So X equals, and so I get plus or minus whenever we square root, and it's a fraction, so I square root the top and square root the bottom. And this is why I didn't reduce the fraction, because 9 is a perfect square root. So there's what X equals. Positive root 3 over 3, which is one number, and then negative root 3 over 3, which would be the second answer. Let's see here. Square root method again. With that, gets rid of the squared right away. And square root of 15, I can't simplify 15. It's 3 times 5. So my last step is just take that 7/5 over, so the k's alone. Now when you write it on the other side, put the negative 7/5 before the plus or minus. It's just the best way to do it. And we're done. It's fine to have a root 15 in your answer. You just can't have roots, radicals in the denominator, and you can't be able to break the radical down further. And that one you can't. Solve for y. Look at this one's got 3 terms. I'm going to add my y to the left side here. And so I'm going to solve by factoring. A is 1, so it's just y and y. And to get a 12, I'm going to use 3 times 4. I'll make the 4 positive, 3 negative, so they add up to 1, the b value in the middle. Now don't forget, you got to set each factor equal to 0 to solve it. So when you set the first one equal to 0, you get y is 3. When I set the y plus 4 equal to 0 and subtract 4, I get my other answer. So y is 3 or negative 4. They both make the equation true. 44, same thing, get it equal to 0. So I subtract 7 from both sides, give me what, 48, I believe. I factor, a is 1, so it's going to be simple. And to get 48, 2 and 24, 6 times 8 is 48, and if they're both positive, they add up to 14. Set it equal to 0 and solve it. Same thing, that's what I end up with. Last ones, m squared minus 21, so this time it's m and m, and they got to add up to 0 for a b. Well, you just use a minus 11 plus 11. They add up to 0, and they multiply to 121. Set each factor equal to 0. So that's one way to do it. The other way to do it, rather than factor it, would be, hey, there's no b term, take the 121 to the other side, just square root both sides. Square root of 121 is 11, so you get plus 11 and negative 11. I'm going to do this one the same way. I'm going to subtract 1, and I get 11 this time. And when I square root, I just leave it as a root 11. So the answer is root 11 and negative root 11. But it's fine just to write plus minus. And I believe that is all your problems. So that should help you get through each one on the 50 to 59% work. Good luck. Get it done, everybody.